So now we are going to talk about prime and composite or non-prime numbers. So here is a useful example to go over. It's asking which of the following numbers are prime. The numbers are given 56, 7, 97 and whatnot. The question is what is a prime number and what is not a prime number. So let's write that definition down. So number is prime. So a number is prime if it has exactly two divisors. So one of the divisors is 1 and the other divisor is the number itself. It has to have two divisors. So note 1 is not prime. 1 is not a prime number. Why it is so? There are reasons for that. 1 is not considered a prime number. In the past it used to be considered prime number, maybe about 100 years or so ago, but today it is not considered a prime number. 1 is not a prime number by definition. You will learn more about why it is not a prime number at a later time in your studies, but right now is not the time to discuss it. But so the prime numbers here are 2, 3, 5, 7, 11 and so on. There are these are the prime numbers. Some of the composite numbers are 4, 35, 49, whatever, 100. These are examples of what are called composite numbers. One thing to note is that 1 is also not considered a composite number. 1 is not a composite number. 1 is not a prime number. 1 is not a composite number. It's neither. 1 is the only number that is neither prime nor composite. But yeah, so these numbers, let's talk about these numbers. This number 5, for example, it has only two divisors. There is no other number that divides 5 other than 1 and 5. It has exactly two divisors, so it's a prime number. This number 4 has three divisors, 1, 2 and 4. This 4 is a composite number, or this 35 is a composite number because its divisors are 1, 5, 7 and 35. So actually it has 4 divisors, so it's definitely not a prime number. So 1 is not a prime number or a composite number. Some more facts to know about prime numbers is that they get rarer and rarer as the numbers become larger and larger. So say the number of prime numbers below 100, if we were to plot over the ranges, say for example number n, which can be 10, 100, 1000, and number of primes less than n. If I make a table like this, so number of primes less than 10 is 4. These are exactly 2, 3, 5 and 7. So that's, you can say, about 40% of the numbers are prime. About 40, exactly 40% of the numbers are prime. The number of primes less than 100, there is 25 primes like that. So the fraction of primes is 25%. Number of primes less than 1000, it is 168. So the fraction of primes, you can say, is 16.8%, or you can see that the fraction of primes is decreasing as you increase n. There are infinitely many primes, but their density, you can think of it that way, or the number of primes less than n, the fraction of primes less than n goes on decreasing. So let's answer these questions here. Coming back to the original question, so 56, it's an even number. So even numbers other than 2 are not prime because they are clearly divisible by 2. So this is not prime. 7 is a prime. I happen to know it. 2, 3, 5, 7, we just mentioned it. 97 is an interesting case. It is a prime. So how do you check if something is a prime or not? We'll come to that in a minute. Let's just knock out the easier ones first. 2 is a prime. 1 is not a prime, not composite. 13 is a prime number. 2, 3, 5, 7, 11, 13. 13 is not divisible by any number, you can easily check. Let's consider this case of 97 a little more carefully. So I have this number 97. I can try dividing this number by smaller numbers than it. So for example, I can check, is 97 divisible by 1? Clearly yes, 1 times 97. Is it divisible by 2? 97 is equal to 2 times anything? No, 2 is not going to divide 97 because 97 is an odd number. Is it equal to 3 times anything? No, actually it is not a multiple of 3 because 90 is a multiple of 3 and 7 is not. So 97 cannot be a multiple of 3. Is it a multiple of 4? It's not, because it's not divisible by 2. It cannot be divisible by 4. Is it divisible by 5? No, 100 is divisible by 5, so 97 is not. And similarly, if you continue going like this, you will see that the only number that you can get finally is 97 times 1. So 97 has only 2 divisors and 97 is prime. Let's just make a note here. 97 is a prime number. So that's how we can check if a number is prime or not. And the method that I mentioned here, this checking from 1 to 97, is somewhat slow and there are faster ways of doing it. But this is conceptually how you would check if a number is prime or not. That you start dividing this 97 by 2, 3, 4, 5, 6, 7 all the way. And that way it's somewhat slow. It's a brute force method, but it will work and it will check if a number is prime. All right.